Hello everyone. So today we are going to solve GFG problem of the day, that is rotten oranges. So basically you have given a matrix of n cross m dimension where each cell has value 0, 1, 2. 0 means empty cell, 1 means fresh orange, 2 means rotten orange. So we are supposed to determine the earliest time after which all the oranges are rotten. So basically if you are at any particular position, you can either go up, down, right, left, but you cannot take more than one step. Let me explain you with a test case. So let's suppose you have given a matrix 0, 1, 2, 0, 1, 2, 2, 1, 1, which can be represented in this way. And let's say the 2 is rotten orange, 1 is fresh orange. 0 means nothing. So either 2 can go up, or it can go down, or it can go right or left. So this 2 can rot this one, this 2 can rot this, on the same time this can rot this, and this can rot this. And after this nothing is happening because it's 0, it won't rot this. So only at one particular time everything is getting rotted, so then output would be 1. Let me explain you with the code and I will explain you side by side. So let say the matrix is given of n cross m, and let's declare the row size, and at the same time let's declare the column size of the matrix. And once we have declared this, we'll declare something called q, and we'll store the integer value. So we are storing this in order to store all the rotten oranges which are present, so that we can process them one by one in the order they have entered. Also it will help in determining how many rotten oranges are present in total, right? And let's declare something as fresh orange, fresh count as 0, that is the fresh orange, and the time as 0. Every step takes a unit time as mentioned in the question, right? So we'll traverse through the matrix starting with the row, we'll go till the end, and the same way we'll traverse through the column, we'll go till the end. My bad. And once we are traversing, if in the way we just got that one of the oranges rotten, that is 2, we'll immediately push it into the queue as ing its coordinates. And if it is not happening so, then it means it is a fresh orange, and we will put fresh count as plus plus. And once we are done with all the counting, we'll declare something vector of pair. I will explain this as directions. So as I told that either you can take left, right, or up or down, but you cannot take more than one step. So that's what I've mentioned directions in coordinate as -1, 0, that is up. And also you can go down, either you can go let's say left, and either you can go right. So these are the 4 directions which one can travel. So once we are declared with this, we'll go through the queue, and we'll check till the time it is empty. And while doing this also, if we found that the fresh count is greater than 0, it means there are still fresh oranges present in the matrix and it has not been rotted. Let's say the size of the q is q dot size. And let's iterate through it from starting to end. And like this is a queue, right? First element will enter, then second, then third, then fourth, then it will go out, then it will go out, then it will go out. It will happen this way, right? So if I will just explain this first element as while traversing through each element, that is 0 to size, we'll declare something pair of int that is both the coordinates p equal to q dot front, that is this element. Then lately this would be this element, I equal to 0 1 2 3. It will happen like this. And once we got the element, we will pop it from the queue. We don't need it anymore, and we'll check. We'll declare its x and y as, let's say, p dot first and p dot second. Its y coordinate as p dot second. And once we have declared all this, we'll declare something dir. We'll iterate through directions. I mean, we'll go up, down, whatever. We'll try all the possibilities. And let's say int dx equal to dir dot first. I mean, if it has taken left, we'll take first as x and second as y. It's like that. So same way dy would be dir dot second. And let's say mu x equal to x plus dx, right? If it has taken one step right, it means if it was initially at 2, then 2 plus 1 is 3. It's like that. And the same way we'll declare mu y as y plus dy. And once we are done with this, we'll check that if mu x is greater than 0, or so basically we are checking this so that it would stay within the boundaries of the matrix, so that we could get answers within that. On the same way, we'll check for mu y is greater than 0, and if it is less than m. Makes sense, right? And also on the same time, we'll check that mu x and mu y is equal to 1. That is, if the very adjacent element is fresh, we can directly make it as rotten orange. So basically this is the that Q element which we popped, then we are checking on the same loop, and once we have rotten that, we'll push this particular thing into the queue so that it could rot its very adjacent element. So this would be happening about q dot push new x and new y, right? And once we are done with this, we'll increase the fresh count. I mean, decrease the fresh count. Anyhow, we have rotten it, right? And also we will put time as plus plus we'll increase it by 1, and at last we will return fresh count, or I should say we'll first check that the fresh count is 0 or not. If it is not, then we'll return the time whatever we got, else we'll return -1. I mean, if all the oranges are rotten, it will return the time, and if it is not, it will return -1. Let's check. So this is the corrected code. And also that we have visited all the cell at least once, so the time complexity would be n cross m, and also we are storing everything in queue, so on the worst case if all the oranges are rotten, it would give us space complexity of n cross m. So hopefully it should run.